Let's focus again on the rapid control prototyping. The innovative concept proposed by EICAS to perform rapid control prototyping activities is based on the use of the EICASLAB RCP platform, composed by a standard low-cost PC that, it is worth noting, can be exactly the same used in the modeling and like real-time simulation phase, equipped with a real-time operating system. Two free real-time operating systems at present are available, the Linux RTI and Linux RT Preempt Patch. Then the PC is equipped, of course, with the EICASLAB software suite and with real input-output devices that allow to connect the PC to the real plant. In the EICASLAB RCP platform, the software code is executed in real time, and it is composed by the same application software generated and preliminary tested in like real time in the modeling and like real time simulation operative mode, as outlined in the previous slide, and the basic software, which is automatically generated by EICASLAB and which is able to schedule all the activities of your control system and to manage the hardware input-output interfaces respecting the constraints which are fixed by the user in EICASLAB through user-friendly graphical user interfaces. We now point out some important advantages achieved with this innovative approach. Working with a standard PC and not in an embedded specific hardware implies, first of all, using low-cost equipment. Nowadays, most of the standard PC have multi-core and multi-thread capabilities. The code generated by EICASLAB, composed by application software and basic software, exploits such a capability in order to emulate a network of processors, which typically corresponds to the final hardware architecture that, since the first operative mode, the modeling and like real-time simulation, the EICASLAB user is called to define. Since you can use in rapid control prototyping the same PC used for the modeling and like real-time simulation, you can easily switch from modeling and like real-time simulation to rapid control prototyping and vice versa. This allows to quickly perform rapid control prototyping and to have the possibility to perform further analysis in a simulation environment on the same control algorithm experimented on field. You can easily tune the control parameters and then again move to the real-time environment in order to carry out the RCP trial on the improved control algorithm. Often, during the execution of an experimental trial carried on with embedded hardware, only a limited number of variables of the control system are accessible and can be monitored. But using a standard PC, you have the possibility to record big amount of data in its hard disk. You can perform RCP reading data file, for instance for initializing the parameters or the states of your system, which are the same files used in the first operative mode. You can easily record on the PC hard disk all the data of your interest during the experimental trial execution for advanced tuning and debugging purposes. EICASLAB provides two types of data recording. First, as already available in the modeling and like real-time simulation mode, during the real-time RCP test execution, you have the possibility to record on the disk all the variables of interest of your control functions, creating a set of data files called POST files for performing offline analysis through the POST tool. Then, during the real-time RCP test execution, you can benefit of an advanced recording function called slow motion recording, based on a smart buffering system able to automatically record on the PC disk all the plant input-output and the host command data sent to the controller, to be then processed offline by applying the slow motion technique. Such a technique works like a sort of moviola, allowing the offline repetition of the experimental trials executed on field through the slow motion tool. As already anticipated in the previous slides, having the very same application software in all the operative modes makes debugging and tuning easier and safer. Your application software is not generated by different software tools in the different control design phases. Then, there is no risk to deal with a different application software during the overall control design phases. Moreover, if you modify your code, you do not have to make any transfer of the new code. Note that the platform can be used also in the target mode. We now describe how you can manage in EICASLab the real-time scheduling. First, we recall that a multi-core processor is a processing system composed by two or more independent cores. While in single-core CPU systems it's not possible to execute more than one piece of code at the same time, in a multi-core processor, each core can run a portion of code so that a real concurrent execution is achieved. A thread is a unit of executable code. In a thread-based multitasking environment, all processors have at least one thread of execution, called the main thread, and each multi-threaded process starts with the main thread that creates one or more additional child threads. Multi-threading changes the fundamental architecture of a program. Unlike a single-threaded program that executes in a strictly linear way, a multi-threaded program executes portions of itself concurrently. Then, a single program can perform two or more tasks concurrently. The true concurrent execution is actually possible only in a multiple CPU or multiple core CPU systems. In rapid control prototyping, the control system works directly with the real plant. Then, just the control area and, if you want, a part of the mission area must be scheduled. The scheduling requires to organize the control functions in threads that will be distributed on the cores of the multi-core CPU available in the RCP platform, thanks to the application in EICASLab of multi-threading and multi-core programming techniques. As well as establishing the final control architecture, you have also to cope with the control activities scheduling. That means to specify the period and phase of every implemented control function. Such a scheduling allows to test the control system on the real plant and to emulate the hardware architecture of the final target by using only one multi-core PC platform. Let's now very briefly show how to schedule your activities through the Sim Builder tool. You have at disposal a thread configuration window for defining the threads and assigning them to the cores of the PC platform, and a menu for assigning a thread to each control function. You have an activities scheduling window for fixing the scheduling parameters of all your activities.